All right, so this week's topic is functions. You guys have already been using little functions such as the print function, the input function, the len function. Those are all built into Python. And so a function itself, you can write. It's kind of like a little mini program within the program itself. So to kind of better understand what that looks like, if we look at this one, we're going to define a function called hello. And that function is going to print howdy, and then it's going to print howdy again with 3 exclamation points, and then print hello there. And we're calling that function 3 times down below. So we have hello once, then hello, and hello down here. All right. The idea there is this would be your output. You would see the output of that function 3 times down here. Now, obviously, that one's a little simple, but the idea is if you need to go off and run a little chunk of code, and then you're going to run that code over and over and over, which maybe you guys have already started to see in some of your homework assignments, you're writing the same code over and over and over, all right? It may be a block of if statements. It may be something else that you're doing, but you're going to start seeing yourself repeat code over and over and over. So a function allows us to run that code, and then we can call that function anytime we want to within our program, all right? So to set up and write your own function, we call def, right? And then from def, we give us the name of the function, which should always be lowercase. It will take uppercase. Don't do that because you'll run into issues at the end of the semester when we start working with classes. So you should always have def, and then you should have the name of whatever you want to call your function, all right? Then you have parentheses. Notice in this parentheses up here, we didn't take anything. So it's just an empty set of parentheses. All right. Down here, we're going to define name. So name is what is considered an argument. And if you guys have used the print function, you know that you have to put something in the parentheses, aka what you want to print, right? So you would use print and you say hello, then it would go ahead and print it, just like you would see here with print. You pass in this argument, you're passing in this other piece, it puts this all together and prints it out. Our hello function also needs an argument called name. So anytime we call hello, we must pass name into that function in order for this function to work. Right? So we would call it like this. We would say hello Alice and hello Bob. That's going to give us output that looks like this. Hello Alice and hello Bob. Right? Obviously, those are pretty basic, simple examples. But the idea is that you can create multiple parameters, things that you would like to pass in there. Right? So for example, if we said def and we call this one say hello, we're going to pass in a name, then we print in this here. We call this function of Al, and it would go ahead and print it out just like we would expect it to. Right? So anything we pass into here is usable inside of our function. So if we call this name, then anywhere inside of our little function code that we use name, it will bring in whatever we passed into this. All right. So we're defining this variable name from the get-go when we set up our function. All right. With the function, you can have a couple different results. You can either have the return keyword, in which case we're going to return something back to the end user. So if the one's up above, we're just printing something and then the code goes back on executing whatever, right? We could also return a value. So that function may calculate a bunch of something. So say we need to calculate the age plus 42 divided by 3 to get the mean of averages between, I don't know, whatever we're going to do in that function, right? We would probably return a value, not necessarily print that value back to the user. So we would use the return keyword, and then we can return true, we could return false, we could return the value of whatever we want. By default, it's always going to return true. Okay, so if we don't define the return on this, it's just going to return true back to the user, which probably does nothing in terms of your program. So if we look at this one, we're going to import the random 8, and this kind of goes back to the magic 8-ball problem, right? So we import random. We're going to create a function called getAnswer, and we're going to pass in a variable called answer number. And if that answer number is equal to 1, it's 1, we return this, right? If it's 2, we do this. If it's 3, we do this. We can see all these different responses that would happen on a 1 through 9. And then our main code executes down here. So R equals our random integer between 1 and 9. our fortune is equal to get the answer of whatever random number. So this here is going to give us a random number. Say it's 3, right? R is now equal to 3. We're going to say fortune is equal to the get answer with R. So we're going to pass in whatever this number is, in this case, 3. It's going to go through this checklist, find 3 in our if statements, and then in this case, return the answer as yes. At that point, we will print that result, which should just print out yes. So like a magic 8-ball, you shake it, ask a question, it gives back, in this case, the answer of yes if we had the number 3. If it was 6, we would get concentrate and ask again, et cetera, et cetera. All right. Does anybody have any questions on functions so far, how they're used, why we use them? All right. The main thing for functions is to reduce the amount of code. If you're repeating code over and over and over, or, you know, have multiple things going on in the same program, functions will help reduce your code. And it's important that you guys know how to write functions. 1, it's going to be on the quiz. 2, it's required of the midterm and the final. All right. You can also use functions to organize code. So if you guys get your midterm project, will start to get bigger and bigger and bigger, right? And it's harder to follow because it's 100 lines of code or something like that. You can use functions to break that up into smaller pieces that make more sense. So say you're writing a text adventure game and they have to choose whether to go left at the cave or right at the cave or enter the cave, one of the options, right? You would have a function that would go if they chose left, you would have a function if they chose right, and you'd have a function if they went into the cave itself. Okay? Then you could call on those said functions depending on what they answered. All right. There in Python, there's a value called none. None just is the absence of any kind of value, right? So we've talked about other data types. We have integers, we have floats, and we have strings. We also had what other data type that we've talked about so far? True and false, which is what kind of data type? Boolean. Yep. So you have Booleans, and now you have another one called none type, which just literally means none. So what that would be is if you wanted to set a variable to none to placeholder it, those of you guys coming from computer science, a lot of times in like C++ or some of those other ones, you have to define your variables at the very top of that type of code. You usually set it to none or 0 or something just so it's defined, and then you use it in your code. You don't have to do that in Python. You can just define it on the fly. So this really is for people that are crossing between multiple programming languages. All right. Keyword arguments in the print function. So you guys have used print, but you guys use it in this fashion, right? Print, we throw in some kind of string in there. We may do string concatenation in order to put a variable or something like that together. But the way the print function is written is that it has optional arguments. And the first one is whatever string you wanted to print out to the screen. The second one is called end. And by default, end is equal to a /n, which is a new line separator. That's why when I print something at the line, let me pull up idle here. All right, we got our new file, and I have something like print hello. You'll notice that when I run this, it does the very simple. Here. Prints hello, right? And then goes down to the next line. If we had multiple prints in here, print something like that. It's going to print hello on a line. Then it's going to go to a new line and print my name is Jason, because we have 2 print statements, right? I can set what I want this to end with. So if I say end is equal to nothing on this hello, well, then it won't go down to the next line. It'll just continue on that line and keep printing. On this next one, I have a /n, which tells it it's going down to the new line. All right. This can be handy if you want to print things in certain formats. Maybe I want this to end with a bunch of hashtags. I could do that as well, right? I could also tell it to end with a bunch of hashtags and then a slash in, which would then give me a new line character, but it's after that. Notice here, it will actually print the slash in. If I really wanted this to go in there, I would have to escape those characters and print it out. Just ignore that for now. So end is an option that you can add on print so that you can set up the ending, whatever that may be. All right. So if I print something like cats, dogs, and mice, notice that I'm printing 3 different strings that are comma separated. When I print, it's going to print those with a space in between. Okay. By default, print will print with a space in between. If I wanted that to be comma separated, I could use the sep argument and pass in a comma, and therefore it would print it out with it being comma separated. Okay. Great way for you to remember that is if you're over here in idle, you start typing print, you'll notice it will tell you all your different options that you have, right? So I can print in, I need to first put in whatever I wanted to print out to the user. I can use sep, which by default is a space, and I have end, which has a default of slash in. I had my slash the wrong way. That's why it didn't give me the in earlier before. This would separate this with a new line. So this says separate everything with a space and end everything with a new line, depending on what's going out. And if you wanted it to go to a file and flush, there's other arguments. You don't have to do those. This first one is required, meaning that we have to pass in something into this function. Anytime we define the variable name, sep equals or end equals or file or flush, those are optional variables. So notice I can print, my name is Jason. I don't have to define the end character, and I don't have to define the separator character, right? Those are optional. If I want to change them, then I have to define to overwrite whatever those options are. Am I losing everybody today? Maybe. Maybe not. All right. So this gets us what's called a call stack. And the idea is that you are moving between the different functions as you go through here. So if you call functions from within functions, you can get some pretty interesting results. And by interesting, meaning you can get lost. So if we define a function A, okay, we're going to print A starts, then we're going to call B, then we're going to call D, and then we're going to print the result of A, okay? Well, if we call A right off the bat, that means it's going to go to B. So then we got to go down here to function B. And B is going to say B starts, and then it calls C, right? Well, then we're going to go down here to C. We're going to print C starts pre-returns, which then takes us back to this function. It will then say B returns, send us back up here to A, in which case we're going to call D. So then we got to slide down to D and then go back up. What this means is you got to be careful calling functions from within functions, because the moment I call B here, I now have to shift down and call all of B's code. And if B calls C, well, then I got to call all of C before I can get all the way back up to A when I start. Where do students usually do this? A lot of times what they'll do is instead of using a while loop to start this over, right? So say this is something in their game, and we'll get some examples here, where they want to start the loop back over. Instead of using a while loop, they'll just call the function back over again. Well, that can cause some funky loops that go through there, and you'll get some unexpected output. All right. So be careful of calling functions within functions. You can do it, just be careful how you get nested inside of that. So if we look at this output of this up here, it ends up going to A calls B, then A comes back, then it goes to C, then to B, then to A, then to B, to A, and all the way down at the end. All right. Gets pretty nasty. All right. Anybody have any questions over functions so far? So if I want to create a function, I have to start with what? I think somebody said it, def, right? So we get the def keyword in there, which means we're going to define a function, and then we need to give it a function name. Should that name be capitalized? No, right? We would like that to be lowercase so that we don't get it confused with classes later on. If I have things inside the parentheses, those are called what? What's that? Not quite parameters. You're in the right realm. Arguments, right? So anything that goes inside the parentheses is called arguments. Some of those are required, some of those are not. If they're not required, they have a what? Some variable name and an equal sign, and then some default, right? So if we look at what we're talking about, we come back up here to the hello. This part's required. This part is not. All right. Notice that the required always has to come first. Then you can define any variable or any optional ones down past it. But you always have to do the required ones first. All right. Remember, when you set a variable name like end is a variable that only exists inside that function. So I could have a function called end somewhere else in my program. It only exists within that function. And so that is what we call local scope and global scope. All right. Local scope is only things that exist inside that function. Global scope are something that we can use in the entire program that we've created. So if I have a variable out here in my project and I call it name, for example, and I set it to JSON, and then I have something like job, and we're just going to throw teacher in here. Then I create a function. We could say print profile. All right. And in this print profile, I need it to take in a name and I need to take in a job. Right. Now, because I already named these variables that, I still have to call those in here. But inside my function, I want to call this name and I want to call this job. All right. And then to print this, we'll say something like username or user, let's just say name, colon, and then we're going to do plus name. And we're going to print job plus job. We could say something like user details. And maybe we want to okay. So if we call this little function, if I hit enter right now, what's going to show up on my screen? Or if I run this code, what's going to show up on my screen? Does anybody know? All right, the answer is nothing. I'm going to run this, nothing gets printed. So why did it not print out that code? Exactly. We need to call this function. Just because we define it, we actually have to call that over here in the main project. Notice the indentations here and how this all works. So over here, at some point, I have to call my profile. So I could say something like print, welcome to my project. And then we could say something like print, what is your name, user? Right. And then we could gather the name from the person. So we would say something like name equals input. Or better yet, we could create a function here. And we could call this get info. And then this point is where we're actually going to ask the user what their name is. So we could say something like print, what is your name? Let's move this up here. Input name equals input. Right. And then we could do a check on name to make sure we're actually getting the name. We're not that far yet. We're going to get that here in the upcoming week. So for now, we would just go ahead and break once we get that name in from the user. That gets us out of the while true. And then while true, we could also ask print, what is your job? Now, instead of breaking here, based on what you guys already know, what kind of check could we do to make sure that they at least type something? You guys should be able to do that kind of check based off what you know now. So can you guys think of a way that we can make sure that they typed something? Or in other words, can we make sure whatever they typed is not zero or nothing, blank? So think about last week. We learned what? What was the first thing we learned? If statements, right? So we could do a check to find out whether or not they typed in something or didn't type in something, right? So if we say if name is equal to what? What's that? Yeah, you could do a blank string is one way to check. And if it is a blank string, then what are we going to do? Yep, we could say that is not valid input. Please try again. In which case we would use a continue there, right? And then on an else, we could go ahead and say break, right? What that will do is keep them in that loop until they at least type something and press enter. What's another way of checking instead of a blank string? What else could we check? Absolutely. Great check. So we could do the len of name. And if that is equal to 0, then we could do the same check. Either one of those two checks would be a valid check, right? So we'll use this one here. Same way with job, we would set it up in the same format. So we would say job equals an input. And it's good now to get in the habit of sanitizing. When I say sanitizing inputs, this is what I mean. You're trying to do some kind of check to eliminate errors. Right now, you can't do a whole lot other than make sure that whatever they're typing in is blank. But later on, you guys will get the tools necessary to do that. So we could say if job is equal to blank, then we can just steal this code and throw that in there. Okay. So now I have a name and I have a job. And I eventually want to call the print profile function to print that information out, right? So I could call print profile. And I need to pass in the name and job. In this case, I called in those variables. So I could say name job. All right. Which means down here at the bottom, I'm going to call get info. And if I run this, now notice I didn't remove name and Jason up here at the top, right? So when I print this, what is your name user? I could type in whatever I want. And notice how it's going to call those two functions. The first one is get info. Let me shrink this down here so we can see it. So it called get info, in which case it asked me my name. It then asked me my job, and then it called the print profile function in order to print that out in the format that we wanted. And so maybe we want to have a couple new lines up here so that it formats a little bit better. So if I say Sam and I say instructor, notice how it calls it Sam and instructor. So even though I had these variables defined up here, notice they had no effect down at the end print. Does anybody know why that is? There's two reasons, but based on what you guys already know, why would that not print out Jason and teacher? Well, we define those variables up here, right? And then I come in here and I say name equals input and job equals input. What that's going to do in normal code is it overwrites it, right? So yes, I defined them up here, but then I turn around and redefine them down here. and assign them to whatever a user types in. All right. But if I say this down here, something like print name, and I say print job, and then rerun this program, I say I'm Sam, and I am an instructor. Notice it prints the job and name for Sam, but then it turns around and prints Jason and teacher for that name. Well, the reason this works is because these two variables are considered to be in the global scape, which means they're clear over here to the far left, and they are usable throughout the entire program. All right. When I come into get info, I also define a variable called name, but that name only exists within this function. Everybody understand how this works? This is where most people get lost in functions. I defined a variable called name out here. It does not affect the variable that's out here. This is called a global. This is called a local. All right. So this is also a local down here. Then I pass them over here to print profile, in which case they get printed out like this. Now I could call this something like var1 and var2, which case I would call this var1 and this var2, right? I can name these whatever I want. They just have to be the same names that I use inside that function. So when I pass in name, which comes in from here, I pass this into print profile saying I want this to be name. At the moment it goes to print profile, it is no longer called name. It is called var1. Then I can go ahead and use var1 in my program however I want. Same way with job gets renamed to var2. I would use var2 in here. So var1 is a local variable for this function. Name and job is local to this function, and I'm passing them into here, in which case when it actually executes, it renames them. This is the part, again, where people can get confused. It's also why we don't use generic names up here if we are specifically referring to a name and job. If we keep it the same all the way through, there's less chance of confusion going all the way. All right. But when I redefine name to be something else, I cannot affect this global name out here on the outside. All right. This will forever stay Jason or teacher down here for job unless I redefine it. So if I say something like name equals Jack and the job equals student, and then I reprint name and job, all right, I'm going to get var1, var2 not defined because I changed this. I got to change it back. All right, so this time we have Angela and we have a coach. You can see that that printed those details out from these functions. Then it printed out the Jason and teacher up here. Then I redefined the name to be equal to Jack and my job to equal to student, and then called that same function of printing those out, in which case it printed those out. Now, instead of me calling directly print name and print job, I could still call print profile and just pass those names in like name and job. And I would still get the output as we would expect before, but now it's going to be in the fancy format that we had before. So if we have Angela and coach, notice how it prints Angela and coach out in the nice format. If I passed in Jason and teacher, which I had above, it prints it out in the nice format. But when I call just name and Jason or job down here, it will print out the Jack and student because that's what we changed it to. So that's the usefulness of functions. If I'm going to print out user details over and over and over, it makes sense to create a function called print profile so that it prints it out in the format that I always want to see it in. All right. If I want to get new user information, I can call get info in order to get new information from a user. All right. You can also use local variables inside functions. They can be different between the two functions, right? So if I came down here and I said name is equal to Sam, and I said the job is equal to butcher, this name and job is different than this name and job, even though it got passed into the function. And this name and job is different than this name and job. All right. This is why you want to be careful what you name your variables. So this is called local scope. Again, I'm inside this function. This is a local scope because I'm inside the function. These are considered global scope. They're on the outside. All right. If I want to use the global one, say I want to change this name up here, I have to define that inside my function in order to use that. So I would have to say inside this print, say I always want to print that, I would have global name. Now, name inside my function is calling this variable from the outside. All right. But I have to specify global and then name. Then maybe I want to change that name overall. So for example, down here, if I say global name and global job, then I'm redefining getting the user and getting the job, right? Then I'm setting that out. If I go to print this down here, and we say this is Sam, and this is a butcher, you'll notice I get Sam Butcher twice. Well, how did I get that? When I have Jason teacher, right? I called this get info the first time. I typed in Sam Butcher. We would expect that to come out here. Well, when I called just that from the global scope, I got the same details. Well, that's because we changed these variables by setting global name and global job. All right. So this can be handy if you want to always keep a running variable within your project, maybe a name, maybe an age, maybe a bunch of other information, but you want to edit that from within a function, you must call the global statement. And I'm drilling this global thing home because it's the number one thing missed on the midterm exam and the quiz. All right. So if you want to affect a global variable, you must have global, and then you must have the name of the variable. If you just answer global, it doesn't work, right? I have to have a variable name attached to it. Otherwise, it means nothing. Global name, global job. All right. Anybody have any questions on global scope, local scope? Trust me, that part can be confusing. You guys will be in the middle of a project trying to figure out why it's spitting that answer out when it should be this answer. And it's probably because you crossed over your variable names between that. All right. If I don't intend to actually change the variable, but I want to use the variable, then if I actually just started up here and said print name, and I have down here one called print job, it will first look for name and job inside this function, which at this point, it's not defined. Therefore, it will go grab the name and job from the global scape. So if I print this, I get this, and it says cannot access local variable name where it is not associated with the value. All right, well, the reason it can't go get this is because I'm actually defining name down here, right? So say if I call this F name down here and F name for first name, then it goes ahead and prints name up here because it found it in the global scope. But the reason it didn't work the first time is it noticed down here, oh, hey, you're defining that after you're trying to get me to print it. You have to define it before I can print it. Does that all make sense? Same way with job. I'm already down here trying to define it. I should probably call this new job, new job, new job. Now I can go ahead and run that. Then it goes ahead and prints Jason teacher right at the top of inside here. So I can access global variables and I can just print their name or whatever the variable name is. But if I want to edit it, I have to put in the global name first. Then I can treat it however I want. I'm modifying it from the outside. Okay. Let's see what else you guys are going to be interested in. Aha. So exception handling. And this is getting back to where you guys can start figuring out how to troubleshoot what a user's typing in, right? So if we have something like divide by, right? So we define this variable called spam. We are passing in a number that we're going to set as a variable called divide by, and we're going to return the value of 42 divided by whatever variable they sent us, right? So if we put 2 in here, we would get 21.0, 3.5. However, if I put a 0 in, can we divide by 0? No, we can't, right? We are going to get some error. And in this case, we're going to get a 0 division error. Can't divide by 0. Okay. So what we can do is we can use what's called a try and except statement. We're going to try to run this code here, return 42, whatever. However, if we get an exception that is a 0 division error, we're going to print specifically that's an invalid argument. We might even say that's not a real number, right? Because if we typed in letters, we would probably get a different error that would come out, in which case we could accept on that. So try and accept allows us to check to make sure that we're getting valid input. Well, where would that be useful in what we have been done so far in this project? Can we use that when gathering a name and a job? Probably not really, right? However, what if we asked them their age down here? So if we say, while true, print, what is your age? And then we could say age is equal to our input. Now, if I wanted to do an if statement, what could I do here? How could I make sure that what they typed in was a number, right? Well, it's always a string. So what's the first thing we want to do if we check if it's a number? Got to convert it over to an integer, right? So if we say int age, we're going to say if int age is greater than 0. We want to check to make sure they typed in a number greater than 0. And then if it is, we'll print great. And if it's else, print that is not a valid age. All right. If this one is great, we'll break out of this. If not, we'll go ahead and continue and keep them in this loop until they give us a valid age. So if I run this, and I got a name now of, say, Jason, job of teacher, and then it asks for an age, and I type in ASDF, I get an error out of there, right? Because I can't convert ASDF to an integer, and I get a value error. So I could try and accept if I get a value error on this, which means I could try, and then we could indent all this over. And if I get an accept, I can either use a blanket accept or I can accept on a very specific error. The very specific error for this would be a value error, right? So we could use value error and print that is not a number. And then it would try all over again. So now if I have a name, teacher, and I type in ASDF, it's going to tell me that's not a number. We can at least verify that they're typing some number to us. All right. In this case, we used trying to convert it over to an integer and making sure it was greater than 0. Is there another check we could do on age? Make sure we're getting a valid age. The greater than 0 should take care of that, but you're on the right track. The inverse of that. Yeah, make sure they're not 1,000 years old, right? Otherwise, we got problems. And I forgot my garlic. Really, not one person? There you go. I got at least one smile. We're good to go. All right, so we're going to convert that age over, and we're going to make sure it's less than what? It's the oldest person. Call it 110. I don't know. If I live to be 110, it's going to be rough. Okay, so now we're going to check to make sure they're greater than 0. We're also going to check to make sure they're less than 110. And we can make sure we're actually getting valid names or valid ages, right? How could we sanitize this job and name up here above? We're checking to make sure it's blank. That's okay. But what else could we say? Anybody know of a name that only has one character? And don't pretend you're a celebrity. All right. No, right? We should have how many letters make up a name? What's that? At least 2, right? So instead of checking for a blank string, how could we check to make sure there's at least 2? Just use the len function again. Let's make sure that the length of that is greater than or equal to 2. Now we can make sure we actually have a valid name coming in there. Because blank string is a great thing to check, but if they give us one character, it's probably not going to be valid. So we need to make sure that it's more defined and we have something that is greater than or equal to 2. And we could do the same thing with a job. I don't know of a job that's 2 characters. So we could use that same logic here. And put as an end job. All right. So there's 2 things out of this lesson. One, you learn how to write functions. You can now use try and accept in order to clean up your input, but you can also use your while true loops in order to keep them in that until they start typing in true valid input. The goal in all of your projects is I should never see this, right? I should never see red from out your project. I will intentionally try to break your project, especially when we get to midterm projects, right? At that point, I should never see this red or you lose points. In this case, it's like 20 points on your midterm project, right? Just like immediately drops you to a B. So you always type in garbage into all of your project, make sure that it never crashes to this. Instead, it should repeat and say, that's not a number, or that's not the right input. I asked for yes or no, something, and then keep them in that loop until they type something that you want to get out of them. All right. You guys, again, will learn better ways of doing these checks, but for now, this is a great way to test yourself. All right. There's some short programs down here at the bottom of this chapter. You guys can kind of work through those. There's, again, practice questions. They're going to have some practice projects down here, and I encourage you guys to challenge yourself a little bit, but you could just do this one, right? So this one's pretty easy. Add a try and accept statement to, well, it's going for the previous project, but the idea is play a little bit with these try and accepts to make sure you guys are catching something in there, right? It's basically wanting you to do exactly what I did here. We're going to check for age. Can we convert that over to an integer? Great. The difference is between this try and accept here is if I left it on if and I typed anything, I'm going to get errors that would look like this, right? Because it would crash immediately if I try to convert this integer age, which is why a lot of people will take an input and they'll immediately try to convert that input over to an integer. Don't do that. All right. If you do that, you are opening yourself up for the program to immediately crash. Always take in something from the user, then come down here and do a try and accept as to whether or not it's valid, or an if statement or whatever else you need. But put that inside of a while true so that you can keep them going over and over until they hit the desired output. Anybody got any questions on that? Again, functions are something that we're really focusing on to save us lines of code or to break our project up into logical chunks or our program. So practice these. Functions are the number one thing students struggle with in the beginning to why would I use a function or how would I define a function? So practice them. It's the only thing I can say is just come up with a project and start practicing it. In your next homework assignment, you guys will work on that a little bit more as you go through there. where you have to create functions to do a bunch of other stuff. All right. That kind of wraps up functions. If you didn't quite understand some of that stuff I was talking about, this is one of those weeks where jump in here to the old videos and watch the other videos on functions. Should not have lists in there. Go away. I'll take that out of there. All right. Watch these other videos on functions. I present them different ways based on different questions. So I only had like 1 or 2 questions this year. Thanks for everybody being quiet. So now you're gonna have to go watch last year's videos if you guys got questions. All right. You have a quiz this week, quiz 1. All right. That's going to cover everything that we've covered up to this point. It's open book, open note. You just have to start it, or you have to finish it once you start it. Okay. It's set to an hour. And if you guys got a thing sent to me, you should have more time for that. All right. It's only multiple choice, and there's 1 matching question. So if we look at this, since we got time today, well, do you guys want to do a quiz? Well, let me stop the video.